Good day, everybody. Danny Rains here, back with a voice of experience again, and thank IP and Nick and all the other folks at IP that allow me to do this. And each podcast is related to an article that I've either written or I'm going to write for IP Magazine. And this particular one is in light of some things that's just happened in the last few weeks. That's usually what I base all my articles on. Is reports I get or observations I make or questions I get about procedures and safety practices, within our industry. So I've had two or three things happen or not happen, been associated with them. I had to investigate two or three of them, and it all has to do with meter safety. And recently, one of my guys was actually doing observations and after mitigation training of another accident for another company, and I witnessed somebody setting a meter. And this kind of brought it to a head. And he asked the young man, the lineman, that wasn't that young, he'd been there a while. He asked the young man about why he checked the meter base out the way he did. Well, what I want to do is go through some statistics first, and then we'll go through a practical application of a single phase, 12240 self-contained meter base. That's what we're talking about, self-contained metering, not CT, not transformer rated, not current transformers and PTs, potential transformers. We're talking self-contained meter bases. And the reason is, even in the arc flash classes I do, I tell people all the time that a self-contained meter base is as close to an NFPA 70E type situation of switch gear that could have a fault. So you got a 5-sided contained front exit arc that's coming right at you if you're standing in front of that meter base. Usually in switch gear, when we're closing it, we can get to one side or the other away from the hinge door or whatever, and not stand directly in front of it. It's the worst place you can, because, again, just because the cover is bolted on or screwed on the way it's supposed to be, doesn't mean it's not coming off if there's enough available fault current there to bring it off. Well, when this young man didn't check out this particular meter base, and my guy saw it, and then we looked and said, okay, well, let's talk about this a little bit. And he said, well, this is the way we do it. Well, I know in my days, a long time ago, at the company I worked for, we had a 6-point meter base checkout that, I learned very early on in my career, and for a reason. And that is, and I think in today's world, even more so than back then, as far as current diversion and theft and electricians that are working on things. Yeah, if I'd have thought about it, I'd have told Nick I'd just run through a PowerPoint and talk over the top of it and show you what I was talking about. But let me just begin by saying this. If you don't check the low side of the meter base as well as the high side of the meter base, you could be, asking for trouble. You could be opening that door. But that's what happened here. He checked, 120 to ground, 120 to ground, 240 across. Great. Set the meter. Whoa. Why don't you check? Why do I need to check that's not mine. That's the electrician's. I said, well, that's all the more reason to check it. Well, in my case, from my experience anyway, I have seen many a meter base that was not hooked up correctly. I've seen brand new installations, and it depends on the configuration, where the disconnect switch is, where the main panel's at, how it's wired. I've seen sheetrock nails driven through entrance cables, SE entrance cables in walls, and that won't work. And if you don't identify a short before you set that meter, you're going to have one heck of an explosion or mess, or maybe even a terrible fault. Now, I want to deal specifically with 120, 240, 120, 208. From an arc flash perspective, generally speaking, on single-phase meter bases, less than 240 volts. It's very difficult to develop more than 8 cal if you get 8 cal centimeter squared arc, which means that your 8 cal category 2 shirt, pants, hard hat, face shield, if you will, and then safety glasses, hearing protection, and then some kind of leather gloves or rubber gloves with leather protectors, grab-it gloves as we used to call them, would be in order for your PPE. But when you get above 240, 240, 480, 277, 480, then now you're in no man's land. So, and now then the available fault current on some of those meter bases, depending on, say you got a bank of 100 kVA transformers, 167s, or you got a 2500 kVA three-phase transformer, UD transformer, you could have 25,000 amps of fault current in there. Well, then without a proper meter-based checkout, and of course, and my recommendation always is de-energize that meter base before you either set or pull, a three-phase meter base above 240 volts. That's the safest thing you can do. A couple of incidents that we've had that I'd just like to go over is one in particular. I'm sitting here looking at it now on my computer as we go through this thing. We had a serviceman go out to set a meter, and it's just a little small 60 amp meter base, 100 amp meter base, 60 amp panel. That's all it really was. And he goes out, it had been disconnected. So in my company, we remove the meter if somebody moved or something, or there was a problem there. We would basically remove that meter and blank it out, put a yellow seal on it. Well, he went out one afternoon about quitting time. It was a serviceman. He worked after hours, and he cut the seal on that meter base. He proceeded to check that meter base out. He had 120, 240 on the top. And then he went from the neutral to the left lug on the bottom. He had 120 volts. And he went, and then he had 120 volts on the other side and 240 volts across the bottom. And I'm going, okay. Had he not checked that thing out, and what had happened, some creative person pulled a piece of Romex from one house to another and actually jumped out from the next door neighbor who had an active service into this house here. And it was back feeding all the way through. The panel, was closed. Fuses were in place. So he had, and of course, in the unlikely event that it phased, it might not have done a whole lot, but more than likely it would not have phased. And guess what? He'd have had a 240 volt phase-to-phase fault in that meter base, which is now you've got an arc in the box. And as I said, it's hard to get over 8 cal on a situation like that, but that's enough to really ruin your day. And, that's just one occasion. Another occasion for another company, one of my customers that happened a while back, there were parallel services, and that's a whole different animal right there. This was underground service, and it was parallel services, 2 4-volt services going into a trough, if you will, and then it was feeding several meters or more than 1 meter. And they had a problem with it, okay? So they went out there, and they didn't check out the low side of those meter bases. They just checked out the high side. They got their side right on that occasion. There's another occasion when they actually was going to disconnect one, and I'll tell you about it in a minute. But they got their side right. They didn't check out the low side, and the electrician had basically marked they had tape on it on the low side of the meter going into the house or going into the panel, but the panel's closed, and they had moved the neutral into the hot leg position and the hot leg into the neutral position. So when they made it hot, he checked the high side, voltage was good. So, left. About an hour later, they got a fire call at that house, and things were happening. It shouldn't have been happening, and it's because they didn't check it out. Had they checked it out, they would have found, the short. Another occasion is to have load on it. I went down to another customer way down south, and basically they said, we need a meter safety because there's a lot of I guess the summer residents would go north during the the winter residents would go south during the winter, and then they'd move back north. Well, they'd disconnect services and all or whatever when they went back home, and then they'd come back to their summer house, later on when cold weather starts setting in, they'd go back down south. And sure enough, total electric houses, and somebody left something sitting on an electric stove in there, and had, and I guess when you go in a house and you start flipping on switches and nothing comes on, you turn everything else on and see nothing comes on. Well, sure enough, they set the house on fire. When they set the meter, they didn't check for any kind of a potential load on the load side of that meter base. If you take a fluke meter, a multimeter, you can see what's there. I mean, it's either open or it's closed. If it's a complete circuit, there's something going on there. You might need to get in touch with a property owner, manager, or whatever, and say, look, you need to get this cleared up. We can't set a meter until load's off, or your main's open on the inside if I can't get to it to open it up on the outside. And, those are the kind of things that gets us in trouble for sure. The last one was, I never will forget, this one here was really ironic. It could have been really bad, but, as it turned out, it just burnt a hole in the door of a three-phase transformer. But they had a parallel service going into an apartment complex, and they had two different size wire in that three-phase transformer, and it was I think it was I can't remember what size, 500 I believe was going into the panels, to a trough that fed the panels, and then they had a fire pump or either the house lights, one or the other. I can't remember. I think it was the house lights. I think it was just the lighting in the hallway and everything that they furnished, the facility furnished. Well, there was a parallel 4-aught service was feeding all of those panels, and they had an order to disconnect that and where they could actually work on it, but leave everything else on. So they went in there, de-energized the transformer, and they found the first two 4-aughts that was in there. Well, there happened to be a third one that was way behind the 500s that was on the bus bar. And they had split that parallel service up. It didn't appear, they didn't have it marked. I mean, it should, to me, I've always marked that a different color, brown, indicating, hey, if you see brown tape on something, this is a parallel service. You better ring it out once you get it off to be sure you got both ends correct. And they didn't. And of course, they took off the first two they could, and one of them fed the house lights, the other one fed the fire system or something, but they just kind of taped them up and held them back and didn't really wrap them in a blanket or anything. And when they closed the door and then made the transformer back hot, and then it burned a hole in the door about the size of a hard hat, because it was feeding in on one side and back out on the other, and it flopped up back against the door when they closed it. So there's just a lot of reasons why you need to ring things out and check things out. Last but not least is, 277 480 volt meter bases. And it's that's no man's land. Any low voltage electrician will tell you in a heartbeat, if they work on 277 480 volt, if they don't de-energize it and something does happen, there's absolutely terrible things happen as a result of those arcs. And of course, much less getting energized, much less having contact with it. I've talked to several electricians that had those arcs. Just changing out something simple like like a 277 volt, overhead light, in a large building, an office building. The best thing to do is it's not turn the switch off over there at the wall. It's to go find out what's feeding that switch and turn it off and lock it and tag it out the way it should be, the way the standard says, the way 191033 says in the low voltage standard for that. And then, of course, our standard in the utility is 1910-269 paragraph M. And, of course, it says in there that once you de-energize that, if you have not grounded it, check for the absence of voltage and grounded, it has to be considered as energized. So you have to treat it as energized with rubber gloves, cover, and everything else. But unfortunately, folks don't do that. And we've had some horrific flashes in 277 480 volt equipment as a result of that. And I actually had one occasion, which it was, I guess people don't really realize, especially, somebody has not worked on the system very much, just how bad 277 480 volt can be. But when you have 277, even single phase 277, if you get in it face to ground, it's not going to let you go. And if it's not a flash and it's a contact, there's a very good chance that you're going. Because I had one young apprentice that was hooking up a service in a 277 480 volt pad mount transformer. It was a Z bar. He was at Holson. He had skint the wire and was trying to put it in the hole to where he could tighten it up with an Allen wrench. And he couldn't quite see because there was a lot of other runs of 500 or whatever that was on those Z bars going into this big store. And he took his hard hat off to where he could stick his head up in the transformer and see. Well, he was hooking up X2. He stuck his head into X1. And he had a contact on the top of his head. And the electrician hadn't been standing there with him. He was hooking up a fire pump or something for this particular store. Had he not been standing there with a 2x4 right next to him, that's how he got him off the 277. He took a 2x4 and pried him off. And I think they had to use AED on that young man about 2 or 3 times between there and the hospital, the helicopter ride to the hospital. But I believe he did make it, and if I remember correctly. But just to show you how easy it can happen, that's meter bases and hooking up services are, not something to be taken lightly. It needs to be thought through, planned, just like I don't care if you're working a primary. It's the same thing. All your PPE needs to be in place. Don't sacrifice any of that. Plan the job and work the plan. That's always my advice to people now. I've just seen too many things happen over time, and it's just really a sad occasion when something like that does go wrong. So with that, I'm going to close out for today. It's a pretty simple a class or refresher we had this morning on meter-based safety, and I appreciate the time again. I know this subject came up on the IP forum last week, I guess it was, when we had the forum, and I might remind you again too that the second Friday of every month we have that IP forum, 11 o'clock Eastern Standard Time, and we have anywhere from 75 to 125, sometimes even more. Folks come on, and they're all over the country, Canada, everywhere else. And if you have time to join us, put it on your calendar. Would love to have you. And just send in a request or send it to me. I'll be glad to send you an invitation, and you can sit in on it, and you'll find it very interesting and very educational. And this is the kind of things we do on the IP Forum too. So y'all have a good day. Be safe. Take care of one another. God bless, and we'll see you next time.
Howdy, partners. The IP Utility Safety Conference is hightailing into Dallas, Texas this October 22nd through the 24th. Register today at utilitysafetyconference.com.
The views, information, and opinions expressed during this podcast are solely those of the individuals involved and do not necessarily represent those of Utility Business Media and its employees. It is strongly recommended that you discuss any actions or policy changes with your company management prior to implementation.